Hello, geometry. Welcome to the start of topic 8 on right triangles and trigonometry, my absolute favorite topic of the year. I think it is most applicable to life. Right triangles are everywhere. Trigonometry is used everywhere. Pythagorean theorem is used everywhere. And let's start with Pythagorean theorem in lesson 8.1. Now, we've done a lot of Pythagorean theorem this year, so it'll be old news to you. But we are going to talk about two special right triangles, which will be new news in this lesson. Okay? All right, so let's take a look at some stuff here. All right, so this is, of course, Pythagorean theorem. We all know this, right? So Pythagorean theorem works for right triangles, right? It is the sum of the squares of the legs equals the square of the hypotenuse. So just remember that the right angle points towards the hypotenuse. So this C is your hypotenuse, right? And when you do Pythagorean theorem, A and B, it doesn't matter which side's which leg is which, but then that C, that hypotenuse, always has to go by itself. And again, if you're ever confused, it is the longest side too. Okay? But again, we've used this all year long. You know how important it is. Now, there's also a converse. So this is if you know the triangle is a right triangle. You can use the converse to prove that a triangle is a right triangle. So again, if you're given the three sides, if you're given A, B, and C, you would just simply plug them into Pythagorean theorem and see if the left side and the right side are equal. If they are, then you would be a right triangle, right? The three sides would satisfy Pythagorean theorem. All right, so we're going to do a little clever proof here involving similarity to prove the Pythagorean theorem. So it says, given that this is a triangle, we want to prove that a squared plus b squared equals c squared. So in this picture, right, we're going to let this leg, again, why they did x, y, z, I don't know. But we're going to let this be a, let this be b, and then this hypotenuse is going to be c. And I'm going to do it like this because you're going to see in a second what's going to happen. Okay, that's c. All right, so we want to use similarity, right? So remember in lesson 7.4 in topic 7, we would draw the altitude from the right angle opposite to the hypotenuse. Well, the same thing here. So step 1, we're going to draw an altitude. And it's going to be xw. Draw altitude xw. So this is going to go from x perpendicular to that hypotenuse yz. Okay, perpendicular, and there's w. So what I'm going to do now is I'm going to break up the hypotenuse. Oh, sorry, first of all, so that altitude is going to be labeled as d, and then I'm going to break up the hypotenuse into two parts, e here and f here. So again, from this picture, we should know that e plus f is equal to the hypotenuse c. Or c equals e plus f, whatever. Okay, step 2. Now we're going to use our 7.4 information. I'll do it in blue. So we know triangle XYZ, which is the big triangle, is going to be similar to, so now let's move on to the small triangle here. So we know that y corresponds to y, and w is going to correspond to x because of the right angles, right? So if x was listed first, w has to be listed first. Y was second, so y must go second. And then the third letter in this small triangle is x. So there's that correspondence. And then the medium triangle, we know that the big triangle and the medium triangle share z. And again, w is the right angle. So it starts with x, so we got to put triangle w. So z goes last, so z has to go last, and then the third letter goes in the middle. And the third letter for this triangle is also x. And there we go. And again, this is by 7.4 material. Okay, so now we're going to use these to create two proportions. All right, so we're going to create proportions. Now, the hint here is that we want to use A and B twice. Use A and B twice. And the reason is when you solve these proportions cross multiply, you want to do A times A because A times A will give you A squared. and that's going to be part of the Pythagorean theorem. So let's go with the big triangle and the small triangle first. So triangle x, y, z being similar to triangle w, y, x. So in those two triangles, x, y is a, right? So notice that it's used, or it's in both triangles. X, y is here, x, y is there, right? So we're going to use this proportion. I'm going to move this guy up. Okay, so we're going to use xy from the big triangle. It corresponds to wy in the small triangle equals. Now we want to use xy or yx from the small triangle, so that's going to be here, and it's going to correspond to zy. So now we're going to fill in these lowercase letters. So xy is a, wx, so wx is d, zy is c. Oh, I'm sorry, wx, this is wy. I apologize, right? xy, wy. Again, my lettering, I can't read it. Sorry about that. So this is e. zy is your big hypotenuse c, and the xy is again a. Okay, and if we do cross multiply this, right, I'm going to do it right here, you're going to get a squared equals c times e. All right, perfect. All right, now let's do the other two triangles, the big triangle and the medium triangle. So triangle xyz, similar to triangle wxz. So again, I want to use I'm going to use not this time xy, I want to use xz twice, right? Because they involve b. So I'm going to use xz twice. So notice that xz is here, and then it's also there, right? So if I use xz from the big triangle, that corresponds to wz in the medium triangle. And then if I use xz from the medium triangle, it corresponds to yz in the big triangle. So xz is b, wz is f, and that equals yz is c over xz is b. And that would then simplify to b squared equals cf. And now step 4 over here, we're going to combine. So we're going to add, right? And it's going to be a little bit more, but we're going to add. So we're going to take a squared, and we're going to add it to b squared. So that's here and here. So we're taking the left sides and adding them. Well, then the right sides would add together, equals ce plus cf. On this right-hand side, both terms have a c in them. So we're going to factor out that c. That leaves you with e plus f, sorry, out of order. And of course, we know up here that e plus f is just c, so we're going to substitute in c, so c times c, and of course, c times c is c squared. And if we bring down that left-hand side, we get a squared plus b squared equals c squared. So a little clever proof there of Pythagorean theorem for you guys to think about. There are many, many, many ways to prove Pythagorean theorem. Okay. All right, I'm going to stop the video now. We're going to do a couple problems to start the next video using Pythagorean theorem, but I'm going to make 3 videos for this lesson total because this information is a little bit longer, but it's important. All right, so video 2 is coming up.